Hello guys, I am Dr. Tanwar and you are watching Dr. Tanwar's MCQs Physics. Today I will take up a very important topic for NEET, JEE and board examinations. This is optics. I will teach you in two sections, ray optics and wave optics. Before we start ray optics, let us understand one very important question which every student think. What exactly is light? For centuries, scientists tried to explain how light travels and what is its behavior. And this gave us different theories of propagation of light. First is linear or rectilinear propagation theory. This is the simplest idea. Light travels in straight lines called light rays. And this concept explains various phenomena like formation of shadows, reflection of light, refraction of light, and formation of different images. And this is the basic assumption used in ray optics. But this theory could not explain various phenomena like interference of light, diffraction, and polarization. Then comes second theory that is called as wave theory of light. This theory proposed by scientists like Christian Huygens. According to this theory, light behaves like a wave, and this wave theory could explain successfully interference, diffraction and polarization, which linear propagation of light cannot explain. But there was still a problem. What is that problem? Wave theory could not explain photoelectric effect and black body radiations. To explain such phenomena, the third theory came into existence, that is quantum or particle theory. Then scientists like Albert Einstein proposed that light behaves as a stream of package of energies, and these packets called photons. Light has particle nature too. This explained photoelectric effect and quantum behavior of light. Final understanding is dual nature, means the light actually can behave as a wave and as a particle nature. For some problems, it can be considered as a wave nature, and for the other problems, it can consider to have a particle nature. So this is called wave particle duality. Real essence of ray optics are, dear NEET students, before solving MCQs, you must understand the real essence of ray optics, because this chapter is not difficult due to formulas, but it becomes difficult because of the sign conventions, image confusions, assumptions, and there are other certain hidden traps. So in the next few minutes, let us revise the few concepts. What is ray optics? Ray optics studies the behavior of light assuming the straight lines called light rays. This assumption works then objects are much larger than the wavelength of the light. And ray optics mainly deals with and explain the phenomena like reflection, refraction, mirrors, lenses, and optical instruments. And there are certain bigger traps of sign conventions. Most students lose marks here because they forget and they don't properly use the sign conventions. And the Cartesian sign conventions in this rule are measure all the distances from the poles or optical centers. And most important is if the distances to the right side are taken as positive and to the left side are taken as negative, as is shown in the figure. And very important thing is the height of the objects above the principal axis are considered to be positive and below the principal axis are considered as negative. There are few common mistakes which are as follows. Forgetting object distance is usually negative. We sometimes forget it. And confusing concave and convex focal lengths and wrong image signs. Mirror concepts. Mirror formula. For concave mirrors, focal length is negative and they form real image, usually inverted as in the figure. And for convex mirrors, focal length is to be positive. And image always virtual and diminished in size. And there are few traps: mixing real and virtual images, wrong signs of focal lengths, and forgetting magnification signs. The magnification in mirrors is the ratio of the size of the image to the size of the object, or negative of uh, uh, image distance to the object distance. Negative m means image is negative, and if magnification is positive means image is erect. And refraction and Snell's law. Core idea is that when light changes from one medium to another medium, their speed changes, and as a result, the light bends. And it when the light enters from rare to denser medium, it bends towards the normal. And conversely, when it enters from denser to rare medium, it bends away from the normal. And Snell's law is mu1 sine theta 1 equal to mu2 sine theta 2. And refraction traps, confusing denser versus rare medium, wrong bending directions. And there is a golden rule: when the light bends towards the normal means it is entering into the denser medium, I told earlier. And if the light bends away from the normal, then it enters into the rare medium, which we have done earlier. And there is another topic, very important topic, that is the total internal reflection. And the total internal reflection takes place under the two conditions. Number one, light should enter from denser to rare medium, and angle of incidence must be slightly greater than the critical angle. And know what is critical angle? Critical angle is the angle at which light, when incident from denser to rare medium, it goes along the interface line, means the angle of refraction becomes 90°. So critical angle, sine of critical angle is the 1 over refractive index. Students often forget total internal reflection is not possible for rare to denser medium. Lenses, lens formula 1 over f equal to 1 over v plus 1 upon minus u. Minus is taken because the object is towards the left of the lens. And there is a one simple thing. If the distances are measured in the direction opposite to the light rays, then it is negative. And if it is measured in the direction of light rays, then it's supposed to be positive. The objects are supposed to be put to the left side of the refracting edges, refracting lenses. And so convex lens F is positive, can form real and virtual images. Concave lens focal length is negative, as we see in the figure. After refraction through the concave lens, they appears to meet or to come from the point which is to the left side of the lens. Therefore, the focal length is negative in the concave mirrors. And so, image always virtual, erect, and small in size. And few traps are mirror formula and lens formula confusion, wrong local focal signs, and wrong image natures. Power of the lens is reciprocal of the focal length. If f in meters, power is 1 upon meter means diopter. And one thing to be considered in mind, if several lenses are placed in contact, then the power of the combination is equal to the sum of the powers of the individual lenses. And microscopes are viewing the nearby objects, and telescope used for distant objects. Common trap, the students confuse to understand the objective lens function and eyepiece functions. Most important exam tips you have to keep in mind, dear students. Top mistakes which are done in NEET are wrong sign conventions. So you have to be careful about the sign conventions, and mixing mirror and lens formulas. They're different. So when the students mix them, there becomes the trap. And real versus virtual confusion. When the real images are formed, when the light rays after refraction through the lenses or reflection through the mirrors actually meet, they form the real image. And if they appear to come from that point, then the image is virtual. Forgetting image nature. Image is real or virtual. Wrong bending directions. And the toppers adopt certain strategy in the NEET examinations. By following it, you can also build up your stamina and the performance in the NEET. First, determine objective type, mirror or lens type, sign conventions, image nature, then solve the formula. Most important exam traps. Done. Now you have you now understand the real foundation of the ray optics, and trust me, once your concepts are clear, this chapter becomes one of the highest scoring chapters in NEET physics. Now let's proceed to the next step. Batch 1, logical and basic level MCQs. Let's begin your optics mastery journey. Thank you. Thank you once again.